We will now learn how to determine the equation of an altitude. An altitude, which is typically considered the height of the triangle, but it's really just a line that goes from one vertex to the opposite side and is perpendicular to that side. So being perpendicular does not mean that that point is the midpoint. It is just some point on the line or the side BC. Depending on what type of triangle it is, your altitude may be inside the triangle, like this acute triangle. It may be on one of the sides of the triangle, like this right triangle, and it may be outside the triangle, like in this obtuse triangle, or this one. So we're going to determine how to find the equation of the altitude in this triangle here. So I'd like you to start with graphing triangle BIG, again with a ruler. B is at 1, 4. I is at -5, 2. And G is at 5, -3. So with your ruler, join these to make a triangle. And we're going to find the the altitude from B down to side IG. So it's going to stop somewhere on side IG, but it's going to be perpendicular to IG, not at the midpoint. So because it's perpendicular to IG, that means we need to figure out the slope of IG. So the slope of IG, y2 minus y1 over x2 minus x1. And that works out to -5 over 10, and in lowest terms, -1/2. So the slope of IG is -1/2, and because we want to be perpendicular to it, we need the opposite reciprocal slope. So the opposite reciprocal means you have to flip it upside down to make it 2 over 1, or you could just write 2, and instead of it being negative, it will be positive. The symbol for the opposite reciprocal slope, which is a perpendicular line, is this: M for slope, and this upside down capital T means perpendicular. So if the slope is -1/2, the slope of a perpendicular line would be 2. So our altitude needs to go through point B with an altitude, with a slope of 2, which means the rise has to be 2, 1, 2, and the run has to be 1. So your altitude is going to pass through those 2 points and go to the opposite side. Again, not at the midpoint, just at the opposite side, and is perpendicular. The symbol to make it perpendicular is that right angle symbol. Now traditionally, the altitude is just inside the triangle. So you would typically just draw the altitude like that. But what I'm going to get you to do is to just extend that line, and you'll see why later after we draw the 3 altitudes. Alright, so to get the equation, we need the slope and we need the y-intercept. Well, we just calculated the slope right there. So to determine the equation of the altitude, you have the slope being 2, and we have a point at 1, 4. So in y equals mx plus b, you know that the slope is equal to 2. And to get the y-intercept, you're going to substitute the point that you know it passes through, which is b, which is at 1, 4. So 4 goes in for y, and 1 goes in for x. 2 times 1 is 2. And if you subtract 2 from both sides, b is equal to 2. So the equation of this altitude is y equals 2x plus 2. And that's how you find the equation of an altitude. If any of that was unclear, once again, make note of it somewhere in your notes and ask your teacher in the next class. So we're only going to find the equation of that altitude, but what we're going to do is draw the other two altitudes just by eyeballing it. The next one we'll draw is the altitude from G to side IB. Now you can see that that is an obtuse angle, so our altitude for this one is actually going to be outside the triangle. So to go from G to IB, we need to know the slope of IB so that we can get the slope of the perpendicular line. So if you calculated the rise and the run of IB, the slope would be equal to 1/3, which means the slope of a perpendicular line would be equal to -3. So the altitude from G to IB will pass through G and have a slope of -3. So a rise of -3 and a run of 1. And we're going to draw a line with a ruler going through those 2 points. And you can see here, there's your altitude outside the triangle. Lastly, we'll find the altitude from I to BG. So slope of BG, if you calculated rise over run, is equal to -7/4. So the slope of the perpendicular line is 4/7, but positive. So the line passing through point I with a rise of 4 and a run of 7 join those up with a ruler, and once again you can see that all 3 altitudes intersect at the same point. That point is called the orthocenter. What I want you to remember is if you were just drawing the altitude, you would typically keep that line segment within the confines of the triangle. The only reason you would need to extend that altitude past the triangle is if you were trying to find the orthocenter. So this concludes your lesson on how to find the equation of the altitude. Once again, if any of that was unclear, please take note of it and ask your teacher about it the next day. The last video you'll have to watch and make notes on today is the equation of the perpendicular bisector.